Alright, so here we are on the next video of the practice test. In the reaction occurring in a lead acid battery, which element is oxidized? So you got to go through and assign oxidation numbers. Lead 0 right here. It's positive 2 right here because sulfate's minus 2. Oxygen, of course, is minus 2, which means hydrogen is positive 1. Oxygen is over here is minus 2, so that means lead is plus 4. So we see that lead is having both things happen to it. So lead is going from 0 to positive 2, so it's going up in charge and therefore is oxidized. And this lead is going from positive 4 to positive 2, so it is going down in charge, and so it is reduced. So it asks which one is oxidized. So the one going up in charge would be PB right here, which is letter B, is in baboon. Alright, moving to the next page. What is the standard EMF, E circle, for the following reaction? And so problem is they don't have the reaction printed here, so I'm not quite sure how to do that one. Let me check my key and see if there is a printed reaction. No, there's no reaction printed there, so we can't do that one. Number 17 says, what is the standard EMF of the copper zinc galvanic cell? So for this one, they're using something called line notation, and if you're not familiar with line notation from one of our textbook problems, this is the way line notation works. They always give the anode first, and the reactant and the product are separated by one line. And then they show the salt bridge by showing two lines right here. And then they show the reactant and the product of the cathode separated by one line right here. And then the electrons always flow from the anode to the cathode, as we already know. And so that's why the anode is listed first, and then they kind of show that line notation like that. They usually don't put this little dashed line around, they just know that you know that, and they never label the anode and the cathode, they just know that you know the anode is first and the cathode is second. So they want the standard EMF of this cell, so you're going to need an E sheet, one of these standard reduction potential sheets, and you're going to have to find zinc on there, and the zinc's way down here at the bottom, so it's negative 763, negative 0.763, and that's our anode, and remember it's always cat minus an, and so then our cathode would be the copper plus 2, and so if we look at the copper on here, make sure you pick the correct copper, because there's several of them on here, but we want the copper plus 2 going to copper, and that's 0.337, 0.337, so 0.337 minus a minus 0.763, and so that one ends up being, well, when you do it in your calculator, letter A right here, 1.1 volts. Last multiple choice of this video, calculate the E for a cell composed of silver and gold electrons in 1 molar solution in their respective standard reduction potentials right here. So this one is higher, so this one is going to be a reduction in my cathode, and remember it's always cat minus an, so it's going to be 1.68 minus my 0.7991 right here. So subtract those two animals right there, and we end up with 0.88 volts, or at least that's the closest to it on number 18. All right, back with more in a minute.